what are the fire safety requirements when it comes to external wall? Even just now, Mr. Raphael, he's also mentioned that now people start looking up in terms of building materials. They want, because of few fire incidents that happens throughout the world, they want to raise up to choose a better building materials to build in any building or designs. A little bit about our companies. We are multinational companies with 80 years of histories. We produce stone wool insulations for buildings, for industrial applications, and even special industries such as automobile as well as railway industry. The special things about our product is, if you recall back in the previous video, is actually our product mostly is not visible in naked eye when installed in the buildings, but one of the important building material as it enhances the building performance, either in fires, acoustic, or thermals, and a way is provide comforts to building occupants. In Asia alone, we have going strong with 20-year presence. And our office in Indonesia actually located in Jakarta. Some of you may know about Rockwools. Rockwools actually a company brand. It has been in our name for the last 8 years and registered in over 60 countries. So usually when it comes to the insulation name, generic name, we would like to call it as mineral wool, stone wool, because the product is made from the stone. That is the main components. Mineral wool, rock, space wool. Okay. Right, let's start straight away with fire resilience. Okay, this is for this today topic. Here is actually what I want to highlight is a few external fire incidents that happen, and how can we make this a learning process to build and design a safe building. Okay, we have here Jecheon buildings in South Korea. Fire happened on December 2017. It's actually an 8-story building. The fire actually happened on the ground floor due to electrical failure and spread throughout this 8-story due to combustible cladding, which actually unfortunately killed 29 people. It's one of the deadliest fire in Korea history. And Lacrosse apartment is in Australia. Fire happened in November 2014. It's actually happened late at night. Okay, it happened due to actually cigarette butt, causing the fire spread through the external combustible cladding, which is the ACP actually consists of polyethylene core. Luckily, no casualty because people are able to evacuate early. But the thing that I want to highlight here is the aftermath. The authorities actually found that the external cladding is actually not compliant with the combustible requirement and asked it to be removed. And at the same time, the owner has been awarded more than 5.7 million in damages. And the one who actually have to pay the damages, the most actually percentage is the architect, the certifier, and the fire engineer, consists around 20-30%, not the builder. So this actually sparked notion that architect also has to bear the responsibility of the safety of the buildings, as they are the lead consultants. Grenfell Tower, June 2017. I think most of people know about this incident because this is an incident that actually sparked in terms people start to talk about fire safety in the external wall. Again, fire happens actually because of the malfunction on the level 4 of the refrigerator. It spread very, very fast of all these 20th floor. And unfortunately, there are 72 fatality. Okay, the fire is actually happened is because of they have this SCP panel the building is actually fixed with SCP panel with polyethylene core. This SCP panel is actually, it actually acts as a source of fuel. And at the same time, this flammable insulation, it caused the melting and dripping and it caused the fire to spread. And behind that SCP panel, they have this what you other foam insulation, which is the PR and phenolic foam, that also contribute to the rate and extend the vertical fire. And currently, inquiry is still ongoing for this case. So external fire, when it happens, it will have a devastating effect on the life, not to mention the property damage. So roughly just look how does external fire spread. If we look at here, fire can happen, like say in one of the story of that multi-story, and it can spread externally and can cause the fire spread due to combustible cladding through the other story in that multi-story buildings and can cause secondary fire. And if there is a cavity between that cladding, the fire can accelerate and can extend 5 or 10 times original due to this cavity present. A lot of facade cladding materials commonly used. I think everyone know ACP, aluminum composite panel, ACM, they other call it, which sometimes they have combustible material as the insulation core. However, there are also A2 version. When we see A2, is actually a requirement under the European code that mention the product is limited combustible. There are HPL, which is high pressure laminated, which is layering wood and paper fiber, is combustible material, fiber cements, or even stone wool cladding. Do you know that stone wool cladding is actually different than the stone wool insulations that we have, but it's kind of like the fiber cement, but it's actually a little bit what you call it, compressed. Where the main ingredient still stone wool. We do, under our Rockwool International Group, we do have this product called Rockpanel. So common use ACP panel, okay, especially that consists combustible core, some regulation of fire. When they test the ACP panel, they only require the sample to subject to what you call it radiant heat. And this actually is not sufficient enough for that SCP panel to ignite. But the thing is, in real cases, when fire happens, or when they do what you call it full-scale fire test, that SCP panel actually subjected to direct heat. When it's subjected to direct heat, aluminium, we have aluminium insulation and aluminium. Aluminium is very, the metal is high conduct. It conducts the foam core in the middle, causing it to melt, causing it to soften, also causing it to ignite cell. So at the same time, because the aluminium skin is very thin, it also starts to melt and exposing more surface area of that PE foam. And due to that, the flame actually start to spread upward and also downward due to melting of that PE foam. Okay, so that's where you may want to actually start when it comes to designing the external, what you call it, cladding. What are the material that need to that you want to choose that can have good fire safety? So here is actually I want to go through on country which they have like fire safety requirement for the external wall. Let's look first at Malaysia. Malaysia is actually have made it compulsory for any building which is above the 80 meter high. They have the external wall cladding, they have to undergo, we call it full-scale test. Full-scale test. If you look at here in the picture here, is actually 8 meter high with L shape, 2.6 meter and 1.5 meter width. Okay, what they do is they construct this in a way to simulate, is there like cavity barrier, fixture, fitting, or cladding. And this subject to the fire. And you see here, there is a, if you look at here at the bottom here, there is the source of fire. Somehow in the cases a fire happened at the below, how fast they want to check whether the fire spread upward as well as horizontal. That's why they have the L-shaped kind of wall. And the performance criteria that you look at, it almost the same as country that actually go into the BIS 8414 requirements. They look into make sure that certain temperature, the temperature does not exceed certain limits. As well, they look into the mechanical failure, which system does not collapse and does not burn. Okay, for Malaysia, we actually test under BS 8414-1 or BS 8414-2, which is different if you look at here, either mensurate or non-mensurate. In UK, they said that in the building regulation, for any dwelling, institution, residential, the external wall need to be class A1. Class A1 is actually following European code requirement that stated the material is non-combustible, or class A2, which is limited combustible. And below that they do not accept. Okay, they do have certain other compliance where for non-dwelling, they also need to test to the BS 8414, the one that I mentioned in the previous slide, where Malaysia also have need to do the test. Okay, but first and foremost requirement is non-combustible and limited combustible. Similar to Australia, also mentioned that the buildings, okay, have to be the external wall need to be non-combustible, following the Australia test method requirement, almost the same non-combustible to the European code test. And they also what you call alternative solutions. If which is they have to test to AS 5113 is similar to if you remember back the full scale test. Is similar to the BIS 8414. Okay, so either your product non-combustible or performance solutions test to full scale external fire test. Okay, so of these three, I just want to highlight the requirement you must have for this country. They have to follow that regulation to make sure the building comply with the building code. Rockwool actually have done comparison using this large scale test, that one that I mentioned, where they have done a comparison using different type of insulation. Actually, you can get this slide afterwards. At the bottom here, there's a link if you want to read about it more. In this test, they actually construct 7 samples, full scale 7 samples, 8 meter high, that consists 2 of the sample is actually using stone wool insulation. 3 is actually using PIR, polyiso, as well 2 is actually using phenolic foam. And if these 3, you look into reaction to fire performance. Stone wool, A1, higher scarification, PIR, and phenolic foam, combustible material, they only classify as B as well as E. Okay. And at the same time, if you look at here, in this sample, when they construct, you can see that the PIR, the sample 3, 4, 3 anti-7, what do they have? 4 anti-7, what do they have is they have this, what you call it, horizontal barrier and vertical barrier. These 2 is actually construct. Let me just show you later to actually prevent the spread of fire. Okay. What you see here, an example, just for example, sample 4 PIR, they need 4 horizontal barrier and 3 vertical barrier. So basically, if you look at the slide here, sorry, and before that I want to mention, about this 7 sample, sample 3, if you highlight here, sample 4 and sample 6 failed the test, okay? Whereas the other 4 passed. But if you look again, even the combustible material that it pass, they need to have horizontal barrier and vertical barrier to pass the test. But for stone wool insulation, even without the horizontal and vertical barrier, they're able to pass the test. So basically, if you look at here, this is how the construction is, around 8 meter high, around 2.4 and 1.5 meter width. This is where the location of the horizontal as well vertical barrier. Okay, roughly is they need this horizontal and vertical barrier, they need stone wool insulation because of the non-combustibility and high melting point of the stone wool insulation. You construct like this. So just actually want to highlight here, pair R phenolic foam. If like say you want to use insulation, but having horizontal and vertical barrier, if you have a very large wall, because we don't have very large wall, and you have to construct that horizontal and vertical barrier, if you look at here, at every 2.5 meter distance, and for a large building, it's very a lot. So it would be better actually to use a non-combustible insulations. So just a little bit at the end of the test, because the test actually been done for 60 minutes. Picture on how does it look like. The first two is the stone wool insulations. You can see that the stone wool insulation is still intact, but the rest of other is already burnt. Okay. All right. I keep mentioning about this, the word combustibility here. So what does it mean? Combustibility is just a measure how easily a substance that actually bursts into flame through fire or through combustion. Different countries will define test method in terms of combustibility. They have their own code, but mostly follow almost the same test method. Okay, in this case, I just want to highlight in European code. European code follow what you call it EN 13501-1. So when you tested the building material or any material to this non-combustibility test, it already stated that your material does not ignite, does not cause the flame to spread, have a very less heat of emissions, have a very less or no at all smoke or toxic gas emission, do not have any character changing, melting, dripping, tearing. So what this mean by this character changing? Just for example, if you have any fire melting or dripping, it can cause it to spread to other material inside that particular room. Okay, let's say for example that. So under the EN classifications, it have what you call it A until F. That's how they determine the performance, which is A1, the highest qualifications, A2, limited combustibility, whereas B to F is combustible material. So choose insulation. We have higher classifications when it comes to fire performance. Comparing rock stone wool to other type of insulation, how does we compare for fire, reaction to fire non-combustible? We are A1, whereas you can look at here, generic type of other foam, let's say EPF is around E to F, very combustible, PUR, PRR around B to D, okay, or even XPS is around E to F, okay. Another thing that I want to highlight in terms of fire performance is actually what there is another test, what we call it as heat of combustions. It's just measuring in terms of the energy value of fuel that contribute to fire. So how they measure? It measure in what we call it megajoule per kg. So here I want to highlight is gasoline. You know, gasoline is highly flammable. Also can highly, what you call very high calorific value that added fuel to the fire. So gasoline is roughly around 46.7 megajoule per kg. And you see here, the other foam insulation also very high, almost similar to gasoline, okay? Example here for EPS around 39, PRR is around half of it, usually around 26 and 28 megajoule per kg. Whereas for our stone wool, it's very, very low. It does not contribute to any feeling of fire, very, very little, which is less than 2 megajoule per kg. Another thing that we want to highlight, which is in terms of the melting point. Melting point is where we want to look at where the material start to change its state from solid to liquid. If you have a material or any insulation, we have very low melting point. So in the way that it can cause the fire to actually to spread from external to internal. So our stone wool have very high melting point of above 1000 degrees C, comparing, let's say, for example, here, foam insulation, which is around 200 degrees C. So that's the reason why, in terms of fire resistant requirement for insulation, they will choose stone wool insulations because it's able to prevent the heat transmitting to the opposite sides. Now, we look into evidence base, okay? Stone wool actually does not contribute to fire because, as I mentioned, high melting points, we are very stable at very high temperature, non-combustible to EN 13501-1, does not burn, does have zero flame potential and very little smoke development, as well as does not emit toxic smokes. We have no flame retardants, okay? Because some materials actually, they added a layer of flame retardant in a way to prevent the spread of fire, but that material itself is still combustible. So actually the one that provides the fire performance is the stone itself. It gives out the fire resilient property. In terms of what are the solutions that we can apply for external wall using the stone wool insulation? It can be ETICS. It can be, let's say, insulation at the back of the any claddings, okay? It can also be, let's say, here is actually for curtain wall insulations. Okay, so how to choose the right insulation? How do you all prioritize in terms of fire safety? Choose insulation which is demand insulation, which is non-combustible, which has a high melting point, which does not has high significant smoke emission or even release toxic gases, no melting droplet, no significant toxic product of burning. With that, I end my presentations. If you want to know any further, you can go through this our website, rawwoolasia.com. All right.